Sierra Nevada mountains, 1866. 95 feet above a ravine, a lattice of raw timber stretches 1,100 feet across open air, one frame at a time. The bridge relies almost entirely on timber rather than structural steel. No stone foundation runs its length. Every post, brace and beam is locally cut Sierra timber, still smelling of sap, hauled up by hand and pinned together by men standing on scaffolding, with nothing below them but the drop. The railroad needs this crossing finished in weeks, not years, because the federal government pays by the mile of track completed, not by the mile of bridge perfected. Speed, not permanence, is the entire point. By the mid-1860s, 2 companies were racing to link the Atlantic and the Pacific by rail, each paid by the government per mile of line they finished, with steeper rates for harder ground. Where the Union Pacific crossed open Wyoming plains, the Central Pacific had to cross the Sierra Nevada, terrain steep enough that the grade climbed 7,000 feet in barely 100 miles. Stone piers took months to quarry and set. Most iron bridge components had to be manufactured in the east and shipped by sea around an entire continent, a journey of months. Timber, by contrast, could be cut from the forest a few miles up the slope and framed into a working bridge within weeks. For a railroad paid by the mile, weeks beat months every time. The men who framed these trestles were overwhelmingly Chinese immigrants, hired in growing numbers after white laborers proved unwilling to stay on the mountain grade. By 1867, they made up roughly 9 in every 10 workers on the Central Pacific's western cruise. According to later accounts from the men who ran the railroad, the idea of hiring them at scale was first met with doubt inside the company, until Director Charles Crocker countered by asking whether the Chinese hadn't built the Great Wall. The gangs that went on to frame the Sierra trestles were paid around $28 a month, somewhat less in cash than white crews doing the same carpentry and blasting work. And unlike those crews, they had to cover their own food and lodging out of it, a gap in total compensation that could be substantial once board was counted in. They lived in camps they built and cooked in themselves, doing work the company had originally assumed they were too slight to manage. A timber trestle was built from repeating units called bents, a row of vertical posts braced diagonally, capped by a horizontal sill that would carry the rails above. The posts themselves often had to be seated on driven piles or footings dug into the ravine floor before framing could even begin, work done with hand augers, axes and pile-driving rigs, powered by men hauling a weight up and dropping it over and over. Crews framed each bent on the ground using broad axes and adzes to square the raw logs, then raised it into position and pinned it to the bent before it, advancing bent by bent until the last one met the opposite bank. Where a crossing was too long or too deep for a simple run of bents alone, engineers dropped in a Howe truss, a design patented in 1840 that combined timber diagonals working in compression with iron rods working in tension, strong enough to span well over 100 feet between supports without a pier in the middle. At Secret Town, northeast of Sacramento, the finished structure ran 1,100 feet across and 95 feet above the ravine floor, framed almost entirely from lumber that had been standing timber a few weeks earlier. There was no crane lifting the crew into position. Men climbed the framework itself, bracing beams by hand, while standing on beams that were not yet fully fastened. The trade-off built into every one of these bridges was understood from the start. Wood could be worked fast with hand tools and local timber, and it could also catch fire. A locomotive's smokestack threw sparks as it crossed, and a dry trestle after a Sierra summer was exactly the fuel those sparks needed. Crews knew this before the first bent went up. They built the bridge anyway, because a crossing finished this season earned revenue this season, and a fire, if it came, could be dealt with later. Railroads tried to manage that risk without slowing down. Water barrels were a standard defense on many finished trestles, sometimes mounted on platforms built into the deck itself, sometimes simply stationed on the ground nearby, refilled by hand, and meant to be grabbed the moment smoke was spotted. It was a modest defence against a structure that could be a quarter-mile of dry lumber 100 feet in the air, and everyone who worked the line understood that a determined fire, once it took hold, would very likely win before a bucket brigade could reach it. Height carried its own separate risk during construction, with no harness, no net, and men bracing green lumber on beams that could shift under their own weight before the final pins went in. Falls happened, so did fires, on this line and on wooden trestles across the growing rail network for decades afterward. What these crews built, bent by bent, was the physical shortcut that let two railroads meet 4 years after ground was broken instead of a decade later, opening a continental market that reshaped the American economy almost overnight. The Central Pacific stretch through the Sierra Nevada, blasted and framed largely by Chinese labor working for lower pay than white crews doing the same jobs, became the hardest and slowest one section of the entire transcontinental line. How many of those men died doing it is something historians still cannot agree on. Company and press accounts from the period are contradictory and often unreliable, and no full accounting was ever kept. What is not disputed is that the men doing the most dangerous work on the mountain were among the lowest paid workers on the project and remembered the least. Secret Town's trestle did not fall to fire and did not get torn down for scrap. Once the line was earning steady revenue, the Central Pacific sent Chinese laborers back to the same ravine, this time with dirt and rock instead of lumber, to bury the wooden structure they had built years earlier under a solid earthen embankment, permanently removing the fire risk along with the bridge itself. Photographs from 1877 show the fill already underway, dirt carts and mule teams working where the trestle deck used to be. Railroad historians believe much of the timber structure survives to this day, buried and preserved underneath the interstate that now runs past the site. A wooden bridge nobody would guess is hidden inside that hill. Many other timber trestles across the country met a broadly similar fate over the following decades, filled with earth or replaced outright as steel grew cheaper, and railroads wanted structures that carried heavier loads, lasted longer, and needed less constant repair. Fire being only one of several reasons wood eventually gave way. A number of wooden trestles, rebuilt and carefully maintained, are still standing and in service today. These systems shape the world quietly. If you'd like to see more of them documented, consider subscribing, and tell us which forgotten craft or construction method we should uncover next.